Last episode, we turned structure into matrices and pulled patterns out with linear algebra. Now we aim that same machinery at the idea that defines modern AI. So, how does a model decide which words matter to which? Picture a library. You walk in with a question, that's your query. Every book has a label on its spine, those are the keys. You scan the spines, find the ones that match your question, and pull those books down. Their contents are the values. Attention is exactly this: ask, match, retrieve. The match is a dot product, a query and a key that point the same way score high, ones that point apart score low. Do this for every query against every key, and you get a grid of relevant scores, who should listen to whom. Then comes the formula at the core of every transformer, softmax of Q times K transpose, divided by the square root of D all times V. The softmax turns raw scores into weights that sum to 1. The values get blended by those weights, and that division by root D keeps the dot products from growing huge as the vectors get longer. Without it, softmax saturates and the gradients die. This is the whole game in a large language model. Attention is differentiable retrieval. The model learns what to fetch instead of being told, runs several heads in parallel, and each watches a different relationship. Add positional encodings so it knows word order. That's the math behind GPT end to end. Here's the whole thing in one file. We'll take 4 tokens, project them into queries, keys, and values, and compute one attention block by hand. We seed, then make 4 token embeddings of dimension 8. We create 3 random projection matrices, the learned WQ, WK, WV of a real model, here just random. We project to get Q, K, V, then form the scaled scores Q times K transpose over root D. Softmax turns each row of scores into weights, and we multiply by V to get the output. The printed rows each sum to 1. They are true probability distributions, and we see exactly which token each query leans on. So attention is just a learned soft lookup. Next episode we use noise and Gaussians to build images from scratch, diffusion.